Welcome everyone to our Practical Cybersecurity for Control Systems webinar presented by Matrix Technologies. Please note that while this presentation has been pre-recorded, we encourage you to submit questions at any time. At the end of the presentation, I will be available live for Q&A. Before we begin, just a little bit about Matrix Technologies. Matrix has been serving clients in industrial manufacturing for over 40 years. In that time, we've worked with clients around the globe, completing projects in over 45 countries. We're especially proud of the relationships we build with clients. Over 85% of all our projects are with existing customers. We serve many of the major industrial manufacturing sectors, including oil and gas, pharmaceuticals, food and beverage, and many others. From process and facility design to industrial systems, automation, and manufacturing intelligence, Matrix is a full-service resource for any automation or engineering project. Just a little bit about myself. My name is Dan McKarns. I'm the Associate Technology Manager in the Operational Technology Systems Infrastructure Group. Yeah, I know that's a mouthful. Our group handles design and configuration of servers and virtualization infrastructure, industrial networking, service delivery architecture, and last but certainly not least, cybersecurity and data protection. And since it's why we're all here, let's get right into what we'll be covering today. Today's presentation will be covering the following topics at a fairly high level. The main focus will be on what things can be done to improve cybersecurity posture within a control system and why doing them makes a difference. For the most part, I will not be covering any specific how relating to these topics, as the specifics of how each of these are achieved can vary from system to system. Some of these suggestions you may already be implementing. My hope is that wherever your control system is on its cybersecurity journey, you find some ideas in this presentation to improve it. Jumping right in, let's talk about the very basics of cybersecurity. I think it's helpful to first state what it is not. Cybersecurity is not a destination or some fixed desired state the system must reach, which once achieved, one can sit back and relax. Security is not a static affair because threats are not created by static actors. It's often referred to as a cat and mouse game. Our stance regarding management of change largely determines whether we are the cat or the mouse. In information and systems security, there are three tenets that make up the root of what it means to be secure. Confidentiality is concerned with the achievement of a necessary level of secrecy and that unauthorized disclosure is prevented. Integrity, on the other hand, deals with the confidence that a system and its information is accurate and that no unauthorized modifications have been made. Lastly, availability, which is often the first concern in control systems, relates to whether reliable and timely access to data and resources by authorized individuals is maintained. The three principles of the CIA triad, as this is often referred to, are further implemented through the hardware, software, and communications that make up a given system. In the simplest terms, security of information can be thought of in relation to change. How does the system change? At the basic level of securing anything, whether that be hardware, software, or users, is the principle of visibility. It's impossible to secure something if you don't know you have it. Security, by the definitions we just went over, is measured in methods of change. Actively managing physical assets is the basis for managing change within them. This, of course, starts with what you have and their current state of configuration, including firmware levels, connections, locations, makes, and models at a minimum. The more visibility you have about your physical assets, the easier it is to see when changes occur or are attempted. This means active management is not simply about maintaining lists with this information. An active system should be used to keep track of assets in real or near real time, capable of reporting on any changes. Also remember that communication between hardware and software provides additional context. So tracking network traffic along with firewall and switch configurations falls into this category. Hopefully this is no surprise at this point, but you'll find that the term actively manage is a reoccurring theme here. Not only are we concerned with hardware assets and their state, but the software running on it. Key tracking points here include operating system versions and patch levels, as well as applications, their versions and patch levels. Additionally, application and operating system service configurations should be tracked. This includes things like DNS and Active Directory objects as they change, and HMI and SCADA project files and their configs, as well as historian's configuration. Our goal here is not just to track things we expect to change, such as process data, which is often tracked by a historian for the purpose of process improvement and compliance, but the configuration of the system itself. Starting off, let's talk about the user security and what we should be trying to strive for. As I stated previously, users are the agents of change. By properly managing users, we can more accurately answer the question of who did what and when. We can further put restrictions on the whom, the what, and the when. This list is a summary of methods and practices that serve as a foundation for answering these questions and the controls that allow creating desired restrictions. We'll visit each of these in more depth in the next few slides. Credential sharing creates a problem of attribution. It obfuscates the real who from our who did what and when requirements. It also reduces our ability to create effective controls around role differentiation, as the system effectively sees all users sharing the same account as one, and are thus authorized to do anything that the user can do. I've seen many systems that operate this way, often out of convenience to operators and administrators maintaining the system. While I understand the reasoning for this approach, which is often rooted in concern for potential disruptions to operations, there are better ways to maintain a high degree of convenience while not sacrificing on security. Even if the credentials are never maliciously or accidentally shared with an attacker, having a shared credential of any type reduces the effectiveness of any efforts to govern its use. A legitimate user that leaves the company still knows those credentials. This goes for both operators and is particularly dangerous when talking about privileged credentials, such as generic administrator accounts. People often reuse the same passwords across multiple systems, and they make the passwords simple or predictable to help them remember. When password requirements make passwords reuse harder, or the change cycle across disparate systems is not the same, keeping usernames the same is difficult. The ensuing result is that people forget both usernames and passwords and resort to writing them on sticky notes or other insecure methods. The solution to this is to reduce the number of isolated credential domains in the control system, ideally to one. A user that can use a single credential across multiple assets is much less likely to suffer from credential fatigue. An additional benefit of having a single user credential across different assets within the system is that it makes it much easier for administrators to manage. A central location to manage account creation, credential lifecycle, and permission provisioning greatly increases the chances of the system being maintained well, especially if there are limited staff to do so. To achieve centralized credential management and the benefits of a one user, one credential environment, assets must be joined to a common identity provider that can act as a central location for identity origination, credential authentication, and permission authorization. While not the only one, the standard identity provider for on-premises systems is Microsoft Active Directory. Note that there are multiple ways to integrate assets with an identity provider, and depending on the asset, multiple integrations may be necessary to fully gain visibility and control. An example might be a machine which runs a local industrial computer driving the local HMI and historian. Integrations may need to occur for the OS, the HMI application, and the historian. Once a centralized identity provider is in place and assets are integrated with it, permissions delineated at the asset level need to be linked to centralized security groups in your credential provider's directory. Again, Microsoft Active Directory is the standard here. By linking in this way, all user permissions can be managed at the central Active Directory level. It also enables further simplification by consolidating like roles across otherwise independent machines. For instance, machine A and machine B might both have the concept of an operator's role. By combining those roles using nested security groups, central management of the overall system can be achieved by managing users within the generalized singular security group for operators. As previously mentioned, one of the big benefits from an administrative perspective is that only a single set of credentials need to be created for a person. And when fully integrated, the permissions across the system can be managed from a single place. The reduction in overhead required to manage users and credentials allows us to place tighter governance on them. Users also benefit from a simplified experience on the plant floor. Perhaps one of the bigger but less obvious advantages is that improvements to the controls around the common identity provider increases security across all of the assets joined to it. An example of this might be using two-factor authentication. The prior steps in implementing user security bring us to the point where we are finally in a place where we have some visibility and manageable methods of control. The next step is to assess whether users truly have the right permissions and that there aren't any unnecessary permissions assigned. A least privilege methodology is much easier to achieve and maintain at this point. Here is the time to double down on auditing and visibility using a security information and event management system. Furthermore, a user change management system is also valuable as it can track the life cycle of users and permissions, including desired state and authorization of state change. These are not native features of Microsoft Active Directory on its own and must be added as separate systems. Last but certainly not least, under the topic of basic user security is the principle of convenience. The more time-consuming security is, or the more it is perceived to be in the way of getting things done, the more resistance there will be to it, not only from users, but even from those maintaining it. This is human nature. The need for security is a byproduct of risk, and risk avoidance is a necessary step in getting something done. With that in mind, it's critical to evaluate the human impact on any changes to security. Passwords 20 characters long may be more secure from a brute forcing perspective, but if no user can remember them, and this drives people to writing them down, the overall security of the system hasn't improved. Consider alternative authentication methods that allow increased security without dramatically increasing inconvenience. With all authentication methods, it is always important to evaluate methods of bypass and the difficulty associated with it. Moving on now to infrastructure security, I think we should think of each asset in your infrastructure as a potential entry point. If you were to protect the house, you would first locate each door and window and then focus on securing them. How could you protect the house if you didn't have an accurate depiction of how many doors and windows you have? The answer, of course, is you can't. We'll be going through this list in more detail in the coming slides. Having this inventory is critical to addressing weaknesses in the building blocks of a system. No hardware or software product is perfect from the factory. As vulnerabilities are discovered and patches and corrections are released, Having an inventory of all your assets in real time helps you understand your risk exposure and allows you to plan accordingly. A complete and dynamic inventory also has the ancillary benefit of helping with product lifecycle management. Some flaws may never be patched by the manufacturer. This probability increases as products go out of general support. Operating systems are complex systems and receive many patches, often all at once. Having an inventory of your OS distribution and patch levels once again gives you visibility into your risk exposure. The biggest risks to any system are the ones you don't know about. Inventory empowers you to know your risks, and if you do identify a system vulnerability that you can't immediately patch or mitigate, then at least you can understand your full risk exposure. It'll also help you prioritize which things should be patched first. Similar to operating system inventory, having a list of deployed software and their patch levels is also critical to understanding and managing risk. Understanding in real time the state of the software, you can reduce risks using a combination of mitigating controls until you have an opportunity for patching. Dependency mapping is also valuable here when it comes to how software and hardware components interact. Just remember, no software, or hardware for that matter, is an island. With a full inventory of hardware, software, and applications, a change management system can help you plan and address specific threats identified through internal investigation, as well as those identified using the common vulnerability scoring system. Subscribing to notifications related to your system will reduce the time to awareness about new vulnerabilities, thus reducing the time to mitigation. Network segmentation is all about dividing and conquering. Separating functionality into the smallest feasible groups ensures the least amount of trust is inherently granted across the communications channel. Networks by nature were designed to be trusting. While a flat network may seem easier to manage at first, when it comes to security, there is no substitute for good boundaries and firewall rules to enforce those boundaries. Don't neglect host firewall rules either, as they are the last line of defense before network traffic enters the network endpoint. Viruses and malware are a reality that isn't going away. Give your control system a fighting chance with an immune system. Keep antivirus and anti-malware updated, especially on border access devices such as those found in the industrial demilitarized zone. Also ensure that you have visibility into events on the antivirus system. There are often early indicators of compromise that can be caught from the logs of the antivirus system. Take a default deny approach. Zero trust is the next level in the security journey for all connected systems. While that topic is too large to discuss in depth in this webinar, there are principles of reducing inherent trust throughout. One thing that can be done is to restrict application execution to only those that need to run. This is a change from the more permissive idea that only software that should run will run. Assuming that some bad actor is trying to get the system to do something other than what was intended changes how we view things. And denying software execution of anything not on the whitelist greatly reduces the attack surface. This can be a tedious process, but it has real value. Sometimes bad things happen. Whether it's caused by a hacker or simply a misconfiguration, having a method to restore to a known state is critical. Backups should take into consideration all aspects of a system. This includes the frequency of backups on a given asset, the location or locations where the backup should be stored, the time it takes to both make and restore a backup for a given asset, and the impact the loss of a particular asset would have on the overall system. Backups are only useful, of course, if you can restore them. Take steps to create immutable backups, ones that cannot be modified, and have sufficient copies to protect against failure of the backup media itself. Periodically test the viability of restoring a backup to a test system to ensure your strategy is giving you the protection you expect. Disaster recovery planning. A plan is worth its price in the time and effort to develop it, no question. If the undesirable should happen, having a sound plan will drastically improve both the chances of a successful recovery as well as decrease the time it takes to recover. Practicing for the worst is never top on most people's list. Don't be most people. Lastly, we come to remote access. Remote access security is really about combining all the other aspects of system management into delivering of a particular service, remote access. Proper user management is key. Multi-factor authentication is a must. Ideally, VPN connectivity will be handled by IT, terminating on the corporate network, not the control system. Multi-factor authentication to connect to the corporate VPN, and then additional authentication to the control system domain, where accessing a gateway resource, such as a remote app or a remote desktop server, is ideal because it separates access authorization across two independent systems. This is the one place where a little extra hassle is a good thing. Give users a controlled entry point into the control system. Don't let them connect their untrusted resources, such as their laptops or workstations, directly to the control system. Make them use your software installed on your infrastructure. That way you have full visibility and control. As emphasized earlier, logging and monitoring of all aspects of the control system increases visibility and enables greater security. If there is one place to do this first, it would be the remote access solution. Scrutinize this aspect first, as it is the door by which most entries will occur. Double down on identity assurance when it comes to remote access. While not perfect, multi-factor authentication greatly reduces risks when it comes to compromise of credentials. Avoid SMS-based two-factor authentication if possible, as it is not as secure as other methods such as RSA, Microsoft, or Google Authenticator apps and tokens. Although, if you don't have a choice, SMS is better than nothing. Coordination between IT and OT is crucial when it comes to remote access. Work to create a system that gives the necessary policies and visibility needed across both the IT system, primarily where the VPN connection terminates, and the control system domain. It is in the best interest of both IT and OT to help ensure everyone knows who is connecting to what.